You're on mute, Abhiram, if you're saying something.
So, are you at home in Pune?
Yes, I'm in home in Pune.
Okay.
I hope everyone's doing well at your end.
Yeah. I think we are fortunate so far.
Yeah.
Things okay there?
Things okay there, but you keep hearing stories. It's getting closer every day. It feels like.
Yeah.
Of cases in each building or in the locality and all. So
Right.
one has to be careful.
Yes, absolutely. And you have a big lockdown now, right? A stricter lockdown, something. Or that's only okay. On Tuesday, I guess.
Monday, from Tuesday. That's right.
Tuesday.
Yeah.
Okay.
Is there one in Mumbai right now, or lockdown? Or?
No, there isn't. There isn't one in Mumbai. I think but Navi Mumbai has one. So Thane has one. So Mumbai doesn't. But Navi Mumbai and Thane both have one.
I guess maybe they feel that Mumbai is tapering, or maybe there are other reasons.
I think that is one feeling, but I don't really know. In fact, I was going to. So let us stay back a little bit after this. I want to talk to you about what kind of data are you looking at? Data that you might be getting in Pune? Are you? So I mean, say for example, if they want to restart, it really needs quite a good amount of thinking on how to restart, and also if they can get data regarding transport, regarding how many people actually want to restart, and things like that, I think then the restart can be useful. Otherwise, we are going to do this. We restart and then we again have infections. But if you want to restart, you have to really plan it out very carefully.
I agree. Yeah.
So I don't know. I mean, I don't know whether the government has any mechanism to do this right, whether they are willing to talk to people. I mean, they really should talk to people and try to get some advice, try to get some data processing. I mean, some data analysis will, I think, go a long way.
Sir?
Yeah, we can start.
Yeah. We'll just start a poll to get the demographics of the audience. Meanwhile, you can start with the introduction part.
Okay.
Boshni has started a poll.
Okay.
Yeah.
So, all right. I get started then?
Yes, sir.
Okay. So, good afternoon, everyone. I'm Abhiram Ranade. I'm a professor in computer science. It's my great pleasure to welcome you to this session, and in particular, welcome you to Dr. Mayur Datar. Mayur Datar, as you might know, is an alumnus of our institute. He finished in 1998, and he got the President's Gold Medal that year for topping his entire graduating batch. After that, he went to Stanford, where he did a PhD. He finished in, I think, 2003 or something.
That's right, yeah.
Then subsequently, he was at Google, I don't know how long, but long enough to become a senior research scientist. And then for the last 10-12 years, he has been at Flipkart, and currently he is Chief Data Scientist and Vice President of Engineering. So I think you're all anxious to hear from him. And but I should tell you a couple of things, I think, which perhaps might not be common knowledge. So even before Google Maps was born, Mayur and a team of students put together an application for doing travel planning in Mumbai, and that was actually used by thousands of people in and around Mumbai. And I think I should also tell you that Mayur Datar is a good singer. I have heard him sing in a student function. I think if I remember correctly, you sang this Marathi song, "Kivha Teri Pahate." I don't know. You probably. I mean, I don't know. But anyway, I thought it is a duty of professors to embarrass students a little bit. But anyway, I think all of us are looking forward to what he has to say on what is data science. So over to Mayur.
Thank you, sir. Thank you very much. And indeed, same here. It's a pleasure to be addressing all of you guys. And thank you, Harshita, and thank you to the student body for inviting me. First of all, I hope that all of you are doing well in this pandemic, and that you and your families are safe. Please take care. Obviously, these are tough times for all of us. And I also feel that all of us are very fortunate to be part of this institute, of this great institute that offers such wonderful teachings. So I know you guys are here to find out more about data science, to find out about career options and so on. But I really truly believe that for somebody like you who's already in the institute, I think half the battle is won by having access to such great education and such great teachers. So with that, I think the way this session is going to be organized, we are going to have a 20-minute session where I just set the context about what I think is data science, give you my perspective on it. And in fact, I'm going to borrow a few slides that I used for another similar talk that I had given in IIT Bombay. But I believe a lot of you were not there, so hopefully it shouldn't be repetitive for most of you, at least. And then we'll follow that with a question answer. I believe that is right in terms of format, right? Harshita, please confirm.
Yes, sir. For the starting 20 to 25 minutes, you can speak, and then 20 to 25 minutes, we can have the Q&A.
Great, great, great. So over to you. I think I'd shared some slides with Roshni. Roshni, do you mind projecting the slides, please? Thank you. So yes, I think the title of this talk, which I just made up based on the title of the session, is "What is data science?" Right? And again, this is my personal perspective. Hopefully, there should be a big congruence with what you see in the industry as well. But that's a disclaimer. As Professor Ranade told you, I have been an alumni of the institute, and in fact, I was so glad to see that Sir will be moderating this session. I think one part that he maybe didn't make very clear is that he was my advisor for the BTech project when I was finishing my BTech at the institute. So it's always a pleasure to meet with him, interact with him whenever I get a chance. So anyway, so what is data science? Let's look into what I feel. Next slide, please. Roshni, yeah, there you go. So take a look at these pictures, right? On the left-hand side, you have a picture, an aerial photograph, and if I'm going to ask you, there are, you can clearly see there's a boundary, and there are two distinct areas. One is a slum area or a area with a low-income population, and the other is a more affluent society. And as humans, I think it should be very easy for you to make out which is which, right? Take the next picture where there are two t-shirts, and one of them is a striped t-shirt and the other is a plain t-shirt. Again, as a human, it's very easy for you to tell me which is a striped t-shirt and which is not, right? And finally, as an example from natural language processing, I've written two sentences. One of them is in English and one of them is in French. With very basic knowledge about these two languages, you should be able to tell me which one is the English sentence and which one is the French sentence, right? So why am I giving you these examples, right? And being students and being in an educational institute and maybe perhaps not having seen the industry up close, what you might find surprising is that decisions like these are made billions, if not trillions, of time every day as part of various industries. And in some cases where the scale is not that big, they actually have humans to make such taggings, to make these decisions. But as you can imagine, as your business scales up, you cannot employ humans to do these tasks. And one might even argue that these are mundane tasks, which perhaps may not be even as exciting for humans to solve, right? So the question is, can we employ computers to solve these problems for us? And the reason is very simple. Computers are very fast. They can do it at scale, and they can do it much, much more cheaply than employing humans. And that to me is data science. Like, how can you approximate human decisioning in the context of industry or any other organization? It doesn't just have to be industry. These days, there are applications in government, public sector, and so on and so forth. Next slide, please. So, so what is the promise of data science? And again, the words like data science, artificial intelligence, machine learning are used in a very interchangeable way these days. Like I said earlier, the biggest promise is to make decisions at scale. And that leads to savings in operational cost. Like for example, the t-shirt thing is actually a real world example from Flipkart, where I work as chief data scientist. So as you can imagine, we are a marketplace and sellers upload images of products onto our platform. And whenever I get an image of a product, I need to figure out, what is this product about? Oh, it's a t-shirt. Is it a plain t-shirt? Is it a striped t-shirt? What is the color of the t-shirt? Is it half sleeves? Is it full sleeves, right? In many cases, of course, we get this information from the seller itself, but you might be surprised to know that not all the time. In many cases, we have to automatically extract this information or put our own operations people to extract this information. So that's a very real application in the context of e-commerce. And it's not just about scaling and savings cost, but sometimes it enables new industries which just would not have been possible. And I give the example of digital advertising in this context. Why digital advertising? So, all of you spend lots of time on search engines like Google, and of course, you spend a lot of time on websites. Now, you'll see that there are ads everywhere. And in fact, in a day, there are billions of ads shown, billions, right? There are billions of the ads that get shown all across the internet. Now, when an ad gets shown to you, what you don't realize that is behind the scenes, there's a lot of processing that goes on to pick the best ad. And typically, to show a single ad to you, there might be thousands of ads that get evaluated, scored in the background. So when you do the math, you can see that you're scoring about a trillion ads every day. As you can imagine, even if you put the entire world's population to solve this task, they cannot do it, right? So digital advertising in its current shape and form at the scale just would not have been possible without data science. And therefore, here's an example of how a new business use case has completely been made possible because of data science. One of the most celebrated professors in data science today, Andrew Ng, go back to the previous slide, please. He said, so what is a good application for data science, right? And he had a simple rule of thumb. He said any task that a human can do in 1 second and for which you have lots of label data is ideal for machine learning. And that is really what a lot of machine learning is about. Like in the past, if you've seen enough data which says that, okay, this is an example of a striped t-shirt, this is an example of a plain t-shirt, this is an slum area, this is an affluent area. And if you see thousands or tens of thousands of such examples, that forms the basis of what is known as supervised machine learning. And supervised machine learning is a big part of data science today. Next slide, please. So how do machines actually try to mimic humans, right? So machines are not smart, right? Obviously, we are the ones who created them. We are the ones who've invented AI/ML. So what we do in machine learning or data science is we say, look, of course, some of the things that we solve are very complex, but let's try to approximate them, right? Let's try to figure out if there is some mathematical function which captures the human decision to a large extent. And like I said, as an approximation, right? So a mathematical function could be a simple linear function. It could be a decision tree. It could be a hyper plane in a high dimensional space that separates two sets of points, and so on and so forth, right? I mean, some of you who have done these courses know what I'm talking about. I'm talking about linear regression. I'm talking about support vector machines. I'm talking about decision trees, right? So what machine learning is about is you're saying you first make an hypothesis that this function can be approximated by this function by this human decision can be approximated by this function family. A function family, like I said, is hyperplanes in high dimensions or a linear function and so on. And then your job is to pick the best function from this family that approximates the data that you have seen. That, in a nutshell, is what machine learning is about to a large extent. And of course, I'm oversimplifying here, but hopefully it will tell you what it is. Next slide, please. Now, some of you might find it a little surprising that, clearly today there is a lot of excitement about this field. And if I can say so, literally millions of people around the world are studying machine learning or applying machine learning and so on, right? But frankly, this is not a new field. It has been around for ages. You can trace its origins to the field of statistics. You can trace its origins to of course, AI, ML, which is the more recent incarnations of it, right? But what has changed recently is three things that I think happened over the last 2 decades or so. So, what are the three things, right? One, as you all know, we talk about Moore's law and how storage and compute is becoming cheaper and cheaper by the day, right? And this started, I would say, in 90s, and starting early 2000s, many organizations around the world, your Googles, Amazons, Facebooks, and then of course later on companies like Flipkart and so on and so forth started collecting a lot of data about how users interact with their products, right? Furthermore, they had immense amount of computing power at their disposal to actually analyze this data. Uh, and so that led to the field of data science. Last but not least, uh, these days you hear a lot about deep learning. What is deep learning? Again, it's not a new area in some sense. It is basically a reincarnation of neural networks. And I remember doing neural networks even when I was an undergrad in 1997. I remember doing that course. But when that course was taught to us, we used to look at neural networks that are 1 layer or 2 layer deep, that have 7 nodes, 10 nodes. So these are toy examples. Today we have taken that old field and made it much more powerful, and that has led to neural networks being able to solve real world problems at scale. And all of these three things coming together, cheap storage, massive computation, and like I said, to some extent, deep neural networks or deep learning has what has led to the excitement about data science. Next slide, please. So, I'm not going to spend too much time, but I thought I would just give you a quick primer on what is deep learning, right? To start with, let's do neural networks in 30 seconds, right? Of course, I'm being, this is a tongue-in-cheek comment. Obviously, you cannot do neural networks in 30 seconds, but think of it as a primer, right? So what neural networks does is it starts with a linear function, y is equal to ax. A is a matrix, ax is a vector. And you can think of y as a scalar. And that is one class of a function, but it is not very expressive. And obviously, you cannot express all functions in the world using a linear function, right? All human functions, human decision making. So you add a certain non-linearity to it. And one form of non-linearity that is often used is something known as a rectified linear unit. And I've shown that there, right? It's like a hinge a function that you see there. That gives you one typical unit of computation in a deep neural network called the neuron. Now you take millions of these neurons, you arrange them in multiple layers, you interconnect them, and the net effect is a very powerful and potentially very expressive function. In fact, there are theories which can show you that any function can be approximated by a neural function and so on, right? But what is equally important about this function is that it is differentiable. The way we have constructed it, it is a differentiable function, and that is important because in order to optimize a function, as you might know, being able to differentiate it makes a lot of difference, because then you can do the standard trick of differentiating it and finding a point where the derivative is zero and hoping that that is a local minima or a maxima, right? So that's basically what these neural networks are about, to a bunch of interconnected neurons which can be optimized with respect to their parameters. Next slide, please. Like I said, this part is not new. What was new is what I'm showing on this slide, right? This is in fact a picture from one of the early papers in deep learning by Google. And what they did is that they said, look, we need to make these networks much bigger, and we need to be able to train them with billions of data points, right? So they came up with two tricks. One is what is known as machine parallelism. That's what you see on the left-hand side. And the basic idea there is, rather than having your entire network fit in one computer, can we distribute it across computers and send messages across these computers while optimizing them and also while scoring the neural network. So that aspect is about machine parallelism. The next aspect on the right hand side that you see is called what is known as data parallelism. So what you do is rather than have a single copy of a network while training, you make multiple copies. Each copy sees a certain sample of the data, but all of these are learning the same function. So what they do is they kind of quote unquote average out the function that they have learned through this parameter server, which is common to all of them, because the function is actually captured through the parameters which are shared across all of these different neural networks, which are split and through which different data points are going on. So these two ideas are at the heart of how to scale neural networks and make them what are known as deep neural networks. Next slide, please. Anyway, I don't want to take too much of your time. This was not meant to be a course in data science by all means, but there are several advantages of deep neural networks. You don't need to do feature engineering explicitly. These neural networks automatically learn the features of images, of sound, and so on and so forth. Furthermore, you can learn a network for one task and reuse parts of it for another task. Just like humans would do, right? Once you've learned how to interpret objects, etc., for one task, you can use it for something else. In fact, neural networks have been, I would say, inspired by the structure of our brain, and that's how the original inspiration for neural networks was. Next slide, please. Long story short, this, like I said, this field has become very exciting today. This graph shows you the number of papers that have been published over the last few years, and the red line is the Moore's law, which means what I'm trying to tell you is that the interest in this area is actually growing faster than how much faster computation is actually becoming in our computers today, right? So that's what this particular graph shows. Next slide, please. So, and finally, the proof is in the pudding, right? We would not have been here today. We would not be discussing machine learning, data science, if that technology had not proven itself. So, what is the proof? What I'm showing you are tasks on which actually neural networks have even beat humans. So, what are those tasks? So, one is image tagging, where you're given an image and you to tag it. Like this is a dog, this is a cat, and not just dog or a cat, but within a dog, you could say this is a Labrador, this is an Alsatian, and so on and so forth, right? Then there is speech transcription, which means you hear a piece of an audio, somebody's talking, and you have to transcribe what the person said, right? So this is also sometimes known as speech to text. Then there is reading comprehension. This is something that we started doing when we were in second grade or third grade, right? You're given a passage and somebody asks you questions about the passage, right? You might read an introductory passage about India. India is a country based in Asia. Its capital is New Delhi, blah, 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 blah. And then somebody will ask you the question, who's the Prime Minister of India? Or what is the capital of India, right? And then from the paragraph, you're supposed to answer that question. So this is known as comprehension. And finally, machine translation, which means you're given a piece of text in one language and you have to translate it to another language. Now, these are just some of the examples in which machines today have become better than humans under some assumptions. Of course, you can always cook up data sets where humans will have an advantage. But if taken from a more regular distribution, today machines are better than humans. And so this kind of success has led to the excitement about data science or machine learning. So I think that was my last slide. Hopefully what I've been able to tell you is, I'll come to this, is that there is a lot of I'll tell you what my view of data science is and why it has become an exciting field today. Next slide, please, the last one. I work in Flipkart, and what I have shown here are how data science is being used in my own company. There are there are literally 15, 16 departments in my company, and each one of them has about a handful of problems in data science. So, for example, how to make recommendations to users. When you type in a search query, how to make sense out of that search query in terms of what you're using for to get the best products for you. How to optimize the placement of products in our warehouses so that it becomes very fast for us to pick these products and ship them to you, how to optimize the route of the delivery guy who comes to your house to deliver your products. There are hundreds of such problems that we need to solve in the context of e-commerce, and that's where we are using data science in a very effective way with a very big impact on business. So hopefully, that tells you how data science is being used in industry, and particularly the industry that I work in today, namely e-commerce. So with that, I'll end my address here. Hopefully, like I said, you have a good idea of what data science is and how it is being used in industry today. Thanks. Harshita, over to you.
Hello.
Yeah, hi.
Yeah, Professor Ranade will take the questions from now. Sir, are you there?
Sir, you're on mute.
Oh, okay, yeah. So let me come to the questions that people have typed in the chat, and then after that we can take some additional questions. Okay, so I think the first question was something like, what should I learn? Should I learn R or Python programming? What is more powerful for data science application? So I think Mayur, perhaps, so please do answer this question, but I think people will have some general questions about what is the path? What do you think is the path that students need to take? So I think maybe you can broaden that question a little bit as well.
Certainly, I will do that. First, the specific question about R versus Python, right? Today, Python is becoming kind of the language du jour of data science, which means a lot of open source development that is happening in data science, various libraries, various frameworks for deep learning, etc., are being done in Python. So clearly, from that perspective, I think Python is a better language to study for data science. But I always say this, that it's not a particular language that is important, because language change from year to year. Every 2 years there might be new language that might come up. So knowing the fundamentals of programming, data structures, object oriented programming, etc., is equally, if not more important, because that ability to adapt to a new language is important. Now, to the more broader question of what is a good career path to data science, right? I think if you look at somebody like me, and I'm very typical person as far as data science is concerned, right? I did my undergraduate in an area like computer science, and like I said earlier, my seminar and my BTech project was from algorithms, was in the area of algorithms. And that I have seen. So if you do an undergraduate degree in areas like computer science, statistics, with in fields like computer vision, algorithms, AI, etc., then you have what is known as the foundations for a data science. But of course, that's not the only way to do that, right? The other ways are, you could, even if your undergraduate is in some other department like metallurgy or mechanical, then you could do a master's in these areas. And these days, a lot of master's degrees are being offered in IITs or in other institutes. In fact, for people who have finished their education, or at least formal education long time back, but who want to get into data science, there are online courses, or what are known as MOOCs as well. And many of this content is actually free, but of course there are paid courses too. So you could take one of these online degrees being offered by institutes like Udemy, Coursera, Udacity. Our own IITs are offering them. A few days back, I saw an announcement from IIT Madras about a very big program that they announced of being able to do masters in data science. So those are some of the typical ways in which you can, gain the theoretical knowledge of what it takes to become a data scientist. At the same time, through these courses, or particularly if you've done your education on your own through these online courses, it's very important for you to get a hands-on experience, and you can do that by writing programs to solve data challenges. There are open source data challenges through competitions like Kaggle, etc. If it's possible for you, you should do internships or summer research programs in institutes like IITs, or like I said, in corporates also there are internship programs. So those are some of the ways in which you can get hands-on experience as well. That to me is a more typical way in which you can get to the path of a data scientist.
Okay, so let me pick up on that answer. So great. I think you mentioned lots of very interesting things. But let's take a typical BTech, okay, not necessarily CS. Say let's just pick one of the disciplines you mentioned. Let's say metallurgy and material science. So suppose somebody is finishing with that degree right now. So he or she has done the standard math courses that are done in the institute. Maybe some additional general background. They may have done some courses related to, I don't know, maybe some organization, some psychology, some usual general courses that might have already done. Given that background, of course they can do a full master's program, but again, getting into a good master's program and figuring out what is the right master's program, all that is somewhat tricky. So does it make sense to say that are there some 4 or 5 courses that sort of are the key courses that a BTech from IIT, let's just make it very concrete right now. So suppose a BTech from IIT Bombay wants to do a career in data science. He has the BTech degree. What is the additional increment that he or she needs to have in terms of courses? I mean, maybe you could even say that, look, this question doesn't make sense. Really, you should go out and get a full degree. That would also be a perfectly valid answer. But just in case there are some 3-4 courses, please give your views.
So I think it is useful to get a full degree, but I agree with you that finding the right masters, getting into the right institute, etc., can be tough, can be tricky. I think in terms of the courses that are being offered in the institute, and pardon me, my knowledge might be a little outdated, but that increment over a metallurgy course or a mechanical course, assuming that you've done a basic programming course, I would say computer vision, natural language processing, then vision, natural language processing, and there are AI, ML. I think AI is also being offered as a more broad-based course, and at least was when we were there. It was, of course, a third year course or a 4th year course. So that's a third course that comes to my mind. And I think some basic foundations of I don't know if such a course exists. I believe it would probably be offered in the statistics department, where they cover some of the older areas like support vector machines, decision trees, regressions, or maybe it is split into a couple of courses in the maths department. So those are the 4 or 5 courses which I would say have a 60-70% overlap with a lot of the, or maybe at least a 50% overlap with a lot of the master's degrees. So those courses, if you can audit, or if there's a way to take them within the institute itself, I think that would prepare you very well for a career.
Or even outside the institute. Or even outside the institute, if you want to do it one course at a time, whenever. Yes. So that might be a good way of doing it.
Yes.
Okay. Let me turn to some other questions that people have asked. Yeah, so I guess one of the questions was, sir, how a non-core engineer should proceed to work in data science? So I guess you have answered that to some extent. Okay, can you tell me about how a data science team in any company works? How is the work divided? So I think what the question is about, so something starts from the level of the customer or whoever your client is, and then how does it develop typically?
Correct. So I think this is a great question, and I'm glad you asked it, right? So the way I see, right, and the way the industry is progressing, Data science is not an aloof field or it's something that you do as an ivory tower research. The way I see it today, how user interfaces were built or UI engineers became core, and then later on they looked as just engineers, right? I think same thing will happen with data science. Data science is just one flavor of engineering that comes together to form a very wonderful or a good product. So to that extent, an entire team needs to come together to form a successful product where data science is applied. And that means you start with a product engineer, or sorry, product manager, who even visualizes what the product is about. Then of course, you design the product, and as part of it, I'm just focusing on the data science aspects of it. You also give thought to, how am I going to log the interaction of my users with my product? What kind of data will I start collecting for various users? It could even be for monitoring the health of my product. It could be to visualize the trends. So some things, this data, what you will do is you'll humanly make sense out of it. But if you have a good system in place to log this data and be able to analyze this data, then that lays the foundation for what later on becomes data science. Because then on top of it, once you have a lot of data collected at scale, and when a new feature wants to be added to the product, which is powered by data science, so it could be using optical character recognition, it could be using computer vision, it could be using natural language processing, it could be using speech to text. You already have the data ready for you. Once you have the data ready for you, then you bring in your data scientist or your analyst who will use that data, maybe collect some training data and build the right kind of models that then get deployed back into it. So in this journey, the important members are, like I said, product managers. Then there are your application engineers who build the basic product itself and make sure that there is the right plumbing to collect data. Then you have your data engineers whose job it is to make sure that you have the right way to store data, to be able to analyze them using the right kind of compute mechanisms, like whether it is SQL queries, like declarative SQL queries, or whether it is more procedural ways like map reduce, etc., etc., to finally your data scientists themselves, whose job is to use all of these frameworks, platforms, to build the right kind of models to solve a concrete problems and then deploy them back into production.
Okay, so you mentioned 3 or 4 job titles in that. So are those people likely to be trained differently, or are they all, do they have the same training to start with and then they just differentiate while on the job?
Yeah, so they will have different training. Now, when I say they will have different training, I would say that a lot of these guys, particularly in IT industry, if it is a product that is a web application or a app on your mobile phone, etc., or even a corporate product, right? If it's an IT product, then a lot of these guys will have some basic degree in computer science typically, but it doesn't have to be computer science, but they're usually engineers at heart, right? They understand technology. Then the specializations, like I said, application developers are more into optimizing the right kind of data structures, the right kind of user interfaces. Data engineers focus more on how to optimally store data, what are the right mechanisms to analyze this data at scale in an optimal fashion, how to do distributed computing, and so on and so forth. The data scientists focus more on the algorithms and the statistics or analytics aspect of it. And the product managers bring in a slight different bent of management and product design. Like, doing user studies, figuring out what are we building, what do the users want, are we solving the right problems for them. So in that sense, they are specialized, and that might be a master's degree that they have done. Somebody might have done an MBA, somebody might have done a master's in data analytics or database systems, somebody might have done a master's in distributed systems, etc.
Okay. I think there are a bunch of questions about your Google experience, starting all the way from what did you do to get a job at Google, and also what was your job like? Okay, so I think perhaps I think people are curious to know this.
Yeah. No, so I joined Google in 2003, and in terms of what I did differently, Well, I mean, I had a good pedigree. I had a good degree from IIT Bombay. I had done a PhD from Stanford, and clearly, such a pedigree helps. But at the end of the day, I think if you look at what companies like Google hire today, these are people with good problem-solving skills. So if you look at the interview process of Google today, and of course, it's been a while since I left Google, and some of the things that I'm telling you about today's hiring process is what I have heard by reading the web or by talking to a few people, right? So with that caveat, if you look at them, they'll actually ask you problems on data structures. They'll ask you problems on algorithms. So they'll give you a puzzle, which is basically a reincarnation of a dynamic programming problem that you have done. So that basic core ability to problem solve, right? They'll ask you an example, right? If you were to design a WhatsApp, which is a simple, well, not very simple today, but a messaging system, how will you do it? What kind of systems will you put in place? So that requires you to understand distributed systems, how to scale them, and so on and so forth, right? So I think that is really what it is about. And of course, all of you guys are from IIT Bombay, so you clearly have a leg up there. But rest assured, I have seen so many people at Google who are from other not so name brand institutes, and they were fantastic engineers as well as the IITians, right? And what made them good is at the end of the day, core computer science skills, problem solving skills, good coding skills, and so on and so forth, right? So that's what matters. Now, in terms of the other part of the question, what did I do at Google, right? I was a data scientist there. I have worked on about a dozen problems or projects while I was at Google. And when I joined them, of course, this phrase data scientist was not very popular back then. It's something that became more mainstream later on. At that time, I was hired with the title of a research scientist. And I worked on, like I said, a dozen projects. To name a few, one of the interesting problems I worked on was, when a user types in a query on web search in google.com, how do you figure out what are the right search ads to target to that user, right? The user has put in something in English. How do you make sense out of it, right? What is the semantics behind that query? What is the user intentions? And based on his or her intentions, what are the right ads to target? Just the targeting part of it, right? Then there are later on there are systems which score the ads and so on and so forth. So you can think of this as a retrieval part of it. So improving that retrieval was one of the problems that I worked on. I was leading the team, so I did this for a couple of years, and we had a great impact on the Google revenue through the various launches that we made. Similarly, I worked on projects in Google News personalization. I published a paper on that in the World Wide Web conference. I worked on YouTube and web search personalization. I have so those are some of the problems that I have worked on when I was at Google.
I think there is a question about all these different terms, but two terms that come up quite frequently are an ML researcher and a data scientist. So what is the difference? Okay. And is there a difference? Should we really worry about the difference?
Yeah.
And yes, could you say something about that?
No, I think maybe the industry will standardize, but today there are a lot of phrases that are used for similar jobs, and similarly a same phrase being used in different ways, right? So we have in fact, I can add a few more terms, right? There is data analyst, there are data scientists, there are machine learning engineers, there are machine learning researchers, there are applied scientists. So there's a plethora of terms, and I wish I had a easy answer for you, but what you really need to do is you need to look at the job description that the company has for that particular term, because it does vary from company to company. And particularly, American companies use certain phrases, Indian companies use certain phrases, but even within India, I've seen examples of people who used to be analysts at Flipkart, and then they switched jobs and they were termed as data scientists in another company, right? So I think it's very hard to define a term here. I can very briefly, in 1 minute, try to define what we call data scientist at Flipkart. So we call somebody as data scientist a person who has the ability to innovate, which means a person who has done a master's or a PhD in AI, machine learning, somebody who is capable of reading papers, of extending that research and being able to publish, somebody who is able to deploy models at scale in production, is typically what we refer to as a data scientist. But like I said, not all companies might agree on that definition, and somebody might refer to the same job using machine learning researcher, for example.
So the description that you gave sounded quite substantially like what an academic researcher might be doing. Is that sort of how it really is at this point? I mean, there isn't a big difference between.
No.
If you were to differentiate between academic research and sort of the job that comes in, both have huge creative aspects associated. But I think perhaps the questioner wants to get into that distinction. Is there sort of a distinction between an ML researcher in an academic setting and somebody who is practicing in, or if that might be the right term, in a company like Google or Flipkart?
Thanks for asking that clarification. I think maybe the way I answered it gave a wrong impression, and I can see why it did. I guess what I was trying to do, I was trying to focus on what is typically different about a data scientist from an analyst or something. So I was trying to highlight those differences, and in doing so, what I ended up doing was focusing on the research aspects of the job. But I think there is an equal, if not a bigger, component of actually building the underlying code. So looking at data, analyzing data, forming hypothesis, then writing, basically creating a quick and dirty version of the model, looking at, doing error case analysis. Is the model doing properly? So there are offline metrics to evaluate a model. You look at error cases where the model didn't correctly tag something, and then go back, do some feature engineering. So that is a huge part of data scientist as well, which I did not elaborate on earlier. And then finally taking that model, then there might be optimization aspects. So finally you built a great model, but it is too big. It is 1 GB in size, and that has to fit on a let's say even a mobile phone, and there only 30 megabytes of memory is allowed, right? So what do? So then you optimize the model at the loss of some accuracy. Today there are some tools to automatically do this optimization for you, but you can do it with yourself as well. So all those aspects are equally, if not more important, and I think my previous response ended up focusing more on the research aspects of it, which is common to the academic researcher that you mentioned.
Okay. Harshita, I think I have sort of looked at all the questions, and I think there are some additional questions as well. But many questions have been partially answered. What is your plan? Do you and the other panelists want to ask some questions now?
So you can take over the additional questions we have. We have still time left.
Okay, but I mean, I just asked this because I think there were some 3 or 4 other panelists which were mentioned. So if they had something to ask, I think they certainly should. Okay, all right. So the other question. So there is a question specifically about aerospace. Are there data science problems and applications in aerospace? Would you like to say anything about that?
Well, I won't answer specifically for aerospace, but what I can tell you is that today the domain knowledge is very important for a data scientist. So in fact, if you come from a computer science background where you might be very good at some of these techniques and the computer science aspect of it, but you may not know the domain very well. Today, a lot of good research and innovations are happening at the boundary of 2 fields. So medicine plus data science, metallurgy plus data science, aerospace plus data science, right? And the knowledge about that domain, in your case aerospace, helps you understand what are the right problems to solve in that area, what are the right assumptions to make, what data, if any, can I get, if not, how can I get new types of data, can I instrument my underlying systems to collect the right data, right? So for example, if I am a mechanical engineer, how can I use IoT to monitor the health of my machines in a shop floor, right? You understand that what are the typical types of machine failures, how do machines go bad. Before that, what kind of signals do they emit, either in terms of a noise, or in terms of a shaking, that domain knowledge that you have. And clearly my knowledge is limited here. I'm just giving you very simplistic examples, but that domain knowledge is very important. I'll give you one other classic example, right? Take forecasting monsoons in India, right? Now you need to be a meteorologist to understand, what are the factors, what data can you even measure that will predict the monsoon in India, right? Your sea surface temperatures, your pressures, and so on and so forth, right? And then once you have that data, you can then figure out what are the right computer science algorithms to solve that underlying problem, right? So I think what you can do if you're an aerospace engineer is you can figure out what are the top problems in your areas that you can solve, that can benefit from using large amounts of data, from using these techniques, and you can bear your domain knowledge to solve the right problem and make a difference to the world.
Oh, fantastic. I think that's a great answer. And I think it might be a considerable measure of relief to several of our students who might be wishing that, look, I really should have been in CS, and why am I in metallurgy, or why am I in aerospace? I think, friends, what Mayur is saying is that the domain in which the problem is being solved is as important, or perhaps sometimes even more important, than the techniques and the solution strategies which are being brought to use. And I think what he's saying is that you should become an expert on the problems, and then once you can formulate the problems, once you can point out which are the right problems, then the solution can come in. But it's an enormous amount of work and ingenuity just to figure out what are the right problems to solve. Okay, yeah. Wonderful. I think that's very nice. Okay, I think yeah, for a particular, yeah, can you suggest any research ideas which can give us opportunity for hands-on learning experience involving GPS, GIS, etc. And I think there was another question was, can you suggest ideas for projects? I'm not sure these are really fair questions, but since they have been put up over here, Mayur, I'll just toss them to you. You can answer them, or you can say whatever you think. But I think these are not exactly fair. Yeah. Go ahead.
It's hard to. I think you're right. It's a little hard to answer that question. I think what I would suggest you should do is, there are very well-known conferences in computer science like KDD, which is knowledge discovery and data mining. I think then there is World Wide Web, etc. Now, as part of these conferences, then there are workshop or data challenges is what they call them. So there's like a competition that they hold, and in that competition, there is a very defined problem with data, tag data, etc., that is available to you. My suggestion would be to go take a look at those problems, and if there is something that excites you or interests you there, go ahead and solve that problem. And I'm sure some of those problems might be related to GPS or GIS and so on and so forth. And another website that I can suggest you is called Kaggle, Kaggle. Again, that there sometimes even companies and all put up data challenges, saying that, okay, here is some sample of our data, here is a problem we are trying to solve. If you're able to come up with a model that has a very high accuracy, let us know. So, or there might be some reward associated with it and so on and so forth. So those are typical resources for getting hands-on problems with access to data and so on and so forth. Now, I don't know specifically related to GPS and GIS.
Okay, so I think given the current situation, I think I should perhaps ask you, can you, so there must be some work going on in tackling, in combating the COVID-19 pandemic. And clearly today, I mean, it is certainly likely to be a data intensive problem. Would you like to say something about this? What kind of work might be going on? What kind of work should be going on? I think that may also be inspirational for our students who are thinking about what problems they should think about.
Yeah, I'll give two answers. I think yes, there is actually a group. Various groups have been formed. I know of one group called Data Science Consortium of researchers across IIC and alums of IITs and ISU have come together, and they have been then interfacing with local government, central government, to basically build models for things like what they see as the progression of the disease. Like for a city like Pune, for a city like Mumbai, Hyderabad, etc., what they anticipate as number of cases with lockdown, without lockdown, for a few scenarios. So that kind of scenario modeling is something that these groups have been doing, and I believe that data is being provided to the government to help make decisions. Actually, some friends of mine, in fact, my IIT Bombay batchmates, not batchmates actually, wingmates, were not from computer science, and they did the study of when you wear a mask and when you sneeze and so on, how do the air particles disperse, and what are the advantages of wearing mask, how effective it is, an N95 mask versus a normal mask, right? So and they published a paper on that particular thing. Now it's not really data science, but it's very useful in the current context, and for the current pandemic. So those are some of the researches that I'm aware of. Of course, what all of us are looking forward to is research in immunology, in vaccine development, and other things, which I am not an expert to comment on. And I'm pretty sure our institutes like NIV and other private companies also are focusing day in, day out on vaccine development, treatment development. So you must have seen how they take the virus culture and subject it to various known chemicals that have already been approved by FDA and so on, to see which chemical is effective on it. And that's how they find out that certain antiviral drugs like remdesivir, etc., are effective. So such things are happening, but of course they require resources. You need labs and other things. So as data scientist, I would say that you can, one of the things that somebody did very early on, this is even before March, is a blog, and I can point to later on, is they looked at graphs of the number of people affected in Wuhan, the deaths, infected people, and so on and so forth. And based on that, they tried to build accurate models for how this disease will progress in various countries. And that led to government policies in terms of how much lockdown, how to flatten the curve so that the hospitals are not overstressed, and so on and so forth.
Okay, you mentioned the group of Indian researchers, consortium of Indian data science researchers. Do they have a website or name or something like that? I think our viewers might want might be able to follow up on that.
Yes. So they do. Let me just quickly see if I'm able to figure out their this thing. Just give me 1 minute.
Sure.
So this is the website. I will cut paste it here.
Okay.
In the
Fantastic.
chat, maybe I can do that.
Yeah.
To all participants.
Okay.
Are you able to see that? I think it is www.covid19datascienceconsortium.org.
I think so. I think we will be able to get that.
Yeah, so
okay. I think I missed out one important set of questions. Okay. So let me ask that. Okay. So there was one question which was about how do you find the difference between Google and Flipkart? And can you say something about the Flipkart environment?
Yeah.
Or how are the challenges in Flipkart different from Google?
No, look, I think both have been very. I'm lucky to have worked in both these companies. Both are fantastic, but there are differences. I think Flipkart is more of a startup kind of a company. It is very agile. It changes policies. It changes strategies, and it's in a hyper growth environment, right? It's in a market that is very competitive, and also a market that is growing rapidly, and that comes with its own unique challenges. Now that's both good and bad, right? I think on one hand, you are presented with these opportunities to solve these hard problems and so on, but at the same time, on the flip side, because as a company you have been chasing such hard targets and running, your engineering systems may not be very mature, your data collection may not be as good as Google, and because your profitability is not as high as Google, you don't have access to resources like Google does, right? So those are the pros and cons of a typical big company versus a small company. But like I said, both have great working cultures and both work on very good engineering problems. At least that's been my experience.
Okay, fantastic. I think, Harshita, I think I have probably looked at all the questions and asked at least a representative question from every group. So I think we are probably close to the end of our time. Is that true? Harshita?
So we can take a few more questions.
Okay.
Probably we can take some questions on higher education.
Okay. So so why don't you ask? Yeah, so I think one of the questions here was how important is higher education to be a successful data scientist, given that many people learn it on their own, doing projects and internships during their undergrad.
Yeah, so one question.
Yeah, go ahead.
Go ahead, Harshita. Harshita, you're on mute if you're trying to say something. Okay, so let me answer. Go ahead. Are you saying anything? You just unmuted yourself.
Yeah. Professor mentioned the question.
Okay.
Yeah.
So I personally feel that it is useful to do a master's or a PhD, so post graduation. And here is my reason why, right? Data science, if you ask me, is not a core engineering discipline, right? It is a more advanced discipline of a core discipline like computer science. And I think to be an effective data scientist, of course, it's good to have the basics of computer science. Like you need to know your programming, your data structures, you need to know distributed systems, etc., right? And that will take up your undergrad. Now, on top of it, this field today is emerging at breakneck speed. So, what I covered with you in 5 minutes about deep learning, etc., that would probably one entire course in master's degree, right? Then there are so many new techniques that have come in natural language processing. There are so many new techniques that have come in computer visions and so on and so forth. So if you want to be at the cutting edge of all of this research, be able to read papers, have somebody to guide you in that, right? So typically what happens in a master's or a PhD is you have these advanced courses which could be paper reading groups where a faculty will guide you, or some other TAs will guide you. Then that is helpful rather than struggle on your own to do that. So to that extent, because it's an advanced field and there is enough research that has happened in this field, I feel there is a lot of value in doing masters or a PhD.
Okay, so I think a related question that somebody has asked is what can you do to keep yourself updated? And is there a sort of a typical career path in this industry?
Yeah, I think to the first part, the way you can keep yourself updated is there's no shortcut. You have to attend conferences. You have to, you cannot do everything. So if you have said that, look, my interest is going to be in computer vision, then try to, I can name, 4 or 5 important conferences in that area, right?
No, but if you are doing a job at a company, would you have the opportunities to go to conferences? Or I think the question is more from the point of view of somebody who is already in a job.
Yeah, I think even in a company, if you're a data scientist, and at least the profile that we consider at Flipkart, right, where being keeping up to date with the latest research, attending conferences, etc., is very much a part of your job description. You are given time to do that. You are encouraged to publish as well. So attending those 3 or 4 conferences, and I'm not saying you to attend all of them. You can attend 1 or 2 of them. And the rest, of course, these days everything is online. You will find the conference proceedings, you'll find talks and so on. So try to keep up to date with the latest papers, particularly related to the specific problem you're solving, etc. Is one way to keep up to date. And then, in fact, the good news about data science is that it is very, it's a kind of a open source culture, which means people don't try to hide their algorithms. They put them out there, they put the code out there. And in fact, even big companies have gone on to open source their platforms like the TensorFlow. They have even open source the models themselves. So Google actually has put out a model to do image labeling, which is trained on their data, right? So I think you can utilize all of that to actually be hands-on and solve problems using some of the latest techniques. And that's one way to stay up to date.
Okay. Very good. Yeah. Okay, I think probably have exhausted all the questions. Is it better to join a big company or a startup during the early phase of data science?
I think it depends. Because see, even in a startup, if you find the right mentor who is going to mentor you, and if they already have collected the data that they need to solve your problem, I think it can be a more fun experience. You will get a more one-on-one mentorship. In a big company, sometimes it's harder to make quick progress. But of course, they'll have more access to resources. There'll be more variety of problems. So it's a trade-off, and so you need to look at what job are you being offered in which group, and similarly on the startup side, what will you be asked to solve? Who's going to be your mentor? Will you learn from him or her? I think those are the important questions you should ask, and accordingly take a decision.
I think there is one question here which I should perhaps put out. Considering the application use of deep learning, what is the role played by the packages like Keras, Scikit, etc. in industries? So are these, I guess the question is about whether these packages are used commonly in the industry or not.
Absolutely. These are used very commonly. Nobody starts writing a deep learning network from scratch these days, or at least when I say nobody, 99%, right? Everyone picks up a library like TensorFlow or something that is built on top of TensorFlow like Keras, PyTorch, and there are many of them. And that makes it very easy. It's almost like a plugin, like drag and drop kind of interfaces. Not really, it's not UI based, but basically, one or two lines of code to add a new layer, to add existing functions, etc. So it makes your life very easy to design and train a deep learning network. So those are some of the libraries that you have been referring to: the Keras, TensorFlow, PyTorch, and so on, and they are used very widely in the industry.
Okay. Does SQL play an important role in your day-to-day life? And how can we learn SQL outside the company environment?
Look, short answer, SQL plays an important role in the data engineering side of it, right? So if you look at the variants of SQL, SQL is typically a declarative language that you'd use on top of a RDBMS. But there are a lot of these semi-structured data sets, and BigQuery from Google or Hive from I forget the open source library's name, but Hive are similar query languages like SQL to extract data or analyze data. So you need to understand how SQL works, how can you optimize an SQL query, etc., to be able to extract data using these declarative languages. To that extent, it is useful. So in terms of how to learn about it, like I said, there are courses like Introduction to Databases that you will find in IITs or other places where they will also teach you SQL and other declarative languages.
I think there is one question: if a student re-implements a good research paper and uses it on a different application, is that a good way to get hands-on experience?
Certainly. Yeah, certainly.
Okay, I think Harshita, I think I probably now have truly exhausted all the questions. Okay. And
Yes, sir.
yeah,
Just an announcement. I'm
yeah,
putting a
please.
feedback form in the chat
Yeah.
box.
Okay.
Everyone, please do fill it. And I think we can wrap up the questions. We have covered all the questions mostly. So yeah.
Okay, I think Mayur, I think many thanks to you for joining us, and wonderful to really have you and hear you and see you. And I think the answers have been quite provocative. I think it has given us a lot of food for thought. And finally, I would like to say to you and to everyone, please be safe. Wear masks. Do everything to keep yourself healthy. Work out, I think, as much as possible. And I think thanks to Tinkerer's Lab for organizing this. So Harshita,
Yeah.
yours.
Yeah. Thanks a lot, Professor and Dr. Mayur, for your time and consideration. I would like to thank all the attendees for attending the talk today. Um, yeah.
Thank you so much, Harshita, once again, and thank you, Professor Abhiram, for moderating this. Always a pleasure to see. Thank you so much.